All right, so we're going to go ahead and get started on explaining these protocols for SPI. So as always, there's a read protocol and there's a write protocol. The read protocol allows you to read a register from the chip of interest. So this register is typically a memory block and it stores data. So in the case of the reading, it'll probably contain the acceleration data that it recently just collected, in the case with our sensor. And there's a write command, which you can go ahead and write to a register. Again, this register is a memory block. In the case of our sensor, this memory block or register in particular could be used to store the sensitivity values or the sensitivity and other options of how it's actually going to read the data itself. So say for the accelerometer, you can change the sensitivity options to be plus minus 2 Gs or plus minus 4 Gs, etc., etc. So there's kind of a challenge with explaining this sort of stuff because every single company actually has their own individual set of read and write protocols. So what I'm showing you right now is just the protocol and how to access this chip. But ultimately, if you want to actually access other devices, you're going to have to read their specification sheet, and they'll go ahead and explain to you fairly clearly exactly how to set up their protocols and make them work so you can actually interface with their source of devices. But with that, one thing that's commonly universal with every single SPI interface is the chip select and the slave select. So it's always set low if you want to actually start to enable reading or enable writing. So enable communication is when the chip select pin gets set to low. And then there's always going to be a clock line that moves up and down just to keep track of time. And in this instance, what this pretty much means right over here, each of these little hexagons indicates a bit that you're transferring through. So the first 6 bits that you transfer through represent the address or the register address that you want to access. This extra bit, the 7th bit, indicates if you want to do a multiple read or write. So the idea with this one is, instead of reading only one register, what you can actually do is read multiple registers. So the idea is what's going to happen is the slave is not going to output just 8 bits of data. It's going to also that represents this register address, but it's also going to output another 8 bits that represents the register address right after this. And over here is the read-write command. So this pretty much enables whether or not you want to actually read a register or actually write to a register. So read is typically a 1, write is typically a 0. All right, so with that, in the case with read, we actually set it to 1 for read, and the master in slave out is actually going to output, after when you transfer this data, the register value. So these are all the data bits that represent what was stored in that register. And this is SPI read for the instance of this chip, the LSM D9S0. Okay, so we just covered the read protocol. Let's go ahead and now cover the SPI write protocol for the case of the chip. And as always, you want to go ahead and send the slave select or the chip select pin down to low. That pretty much means you're going to enable reading or writing on the SPI bus. Now, of course, as always, the clock is going to go ahead and go up, go from low to high to indicate the timing of it. And the only thing that you actually need to know about write is just the outputs of the master out slave in. So the first part is pretty much just like the read. So this one it locates the address, the register address that you want. So this is the register address. This is the multiple read or write command. And right here, because we're writing, this is going to be set to 0. So once we have this once we have the first bit transferred, the second bit is pretty much the second byte. I'm sorry, is pretty much just going to be whatever we want to write that register value to become. All right, so we just covered some of the basic protocols for SPI, and now we're going to go ahead now and cover a few perks about SPI. So one thing to keep in mind is that there are in fact 4 different modes for SPI. So it's mode 0, 1, 2, and 3. And the reason why they have these modes is dependent on the fact that you can actually determine exactly how a bit is interpreted based on where the clock is positioned. So there are 2 parts of the clock that you need to keep in mind. So one of them is the clock polarity and the clock phase. So that's what CPOL and what CPHA stand for. And this illustration pretty much describes exactly how a bit is interpreted depending on these 2 values. So when the clock polarity is equal to 0, that pretty much means that by default the clock is going to be set to low, and then when it actually starts counting things, it's going to start from the low and then go to high and then low and then high and so on and so forth. When the clock polarity is set to 1, that means by default the clock is actually going to be set to high. And then when it actually wants to start to count things, that's when it actually shifts down to low and then to high and then low and to high. Right? So that's the clock polarity. Now for the clock phase, this ultimately determines if a bit is interpreted based off the first change to the clock or the second change to the clock. So when the clock phase is equal to 0, that pretty much means the bit is interpreted on the first change of the clock. So as you can see right here, the first change of the clock right here. So depending on if the clock polarity is equal to 0 or 1, that could mean either the low to high change or the high to low change. When the clock phase is equal to 1, that pretty much means a bit is interpreted on the second change of the clock. So as you can see right over here, that for when the clock polarity is equal to 0, that means when it changes from high to low, that's when a bit is interpreted. So with that in mind, we're going to go ahead and take this information into account and go ahead and figure out which SPI mode we're going to be using for our sensor. So as you can see right here, it starts from high and it goes to low. So we already know therefore know that the clock polarity is going to equal to 1. So we know that clock polarity is equal to 1. So it's either one of these two options, either mode 2 or mode 3. So with that in mind, we're going to go ahead and figure out exactly when a bit is interpreted. So this is where a bit is interpreted, and as you can see, it's when it changes from low to high. So you can see from here, when it changes from low to high, that pretty much means that the clock phase is equal to 1. So when the clock phase is equal to 1 and clock polarity is equal to 1, that pretty much means we're going to be using SPI mode 3. So we're going to keep that in mind when we're writing up our code. Another thing to take into account is that when it comes to actually writing the code up for SPI, there's only really one function used to either read and transfer data, and it's the SPI.write command. So the way the write command works is that it doubles both as the receive and the transfer of data. So how that works is because the data lines are parallel to each other and they aren't one line. The idea is that as you're writing things, you can't at the same time be reading things in. So in the case of this protocol, so the read protocol transaction, so let's go ahead and just look at the first 8 bits. So the first 8 bits, what you pretty much do is you say, SPI dot write whatever you want to write. So the 8 bits that you actually want to write. So I'm just going to say 72 as an example. Okay, for the second set where you actually want to read stuff in, you pretty much say integer value is equal to SPI.write. And this can be anything that you want, but typically the idea is when you're reading stuff, you want to set it to 0. In the case with this spec sheet, you can actually put any sort of garble in here if you want to. It's up to you. But those are the 2 perks. Again, you got to figure out which SPI mode you want, and you only need to use one function, which is SPI.write, to both read and write data.